Hi BC Calculus. This is my last video of the day. I'm so happy. I'm just kidding, I love calculus. I'm so sad. This is 2016, question number 3, no calculator. And this is the FTC question. This is probably going to be one of the questions on your AP exam this year. Just saying. I don't think this topic is allowed for AB calculus now, because of some of the sections that got thrown away. They don't want to squander a beautiful question like this. I really think they're going to give you one like this. And you're going to love it. You're going to think, wow, this is so great. All right, question A, does G have a relative maximum, minimum, or neither at x equals 10? Well, before we do anything else, let's take the derivative of both sides and get more information. And when we take the derivative here, we get G prime x, and here we take the derivative, destroys the antiderivative, the x jumps in, and we get G prime x is f of x. So while this is the graph of f, we're also going to call it the graph of G. And because this is the graph of G, we're going to make a sign chart of G. So this is G prime. So this is G prime. I just wrote directly through the glare. I'm going to rewrite it down here. Sorry about that. So this is G prime. We're going to make a quick sign chart of G prime. It goes from -4 to 12, so we're going to include that. And it hits 0 at -2, and at 2, and at 6, and at 10. And we have negative values, positive values, positive values, negative values, and negative values. Okay. So the question is, do we have a relative minimum at 10? Well, let's see. G prime x was negative and still negative. That meant g of x was decreasing and still decreasing. So we would say at x equals 10, neither max or min, because f prime x did not change signs. And not f prime, g prime x did not change signs. You can say g prime x if you've labeled a sign chart that says g prime x and made these connections, or you could simply say because f of x, the graph of f, did not change signs, or the graph did not change signs. So that's part A, only worth 1 point. Part B, does the graph have a point of inflection at x equals 4? Well, what features of this graph are going to help us learn about points of inflection? And that would be the slopes. So let's go ahead and make a sign chart using well, we don't even need to make a whole sign chart, but let's just do it anyways, right? So it goes from 12 to -4. I have positive slopes until I hit 0. I have negative slopes until I hit 2. Positive slopes until 4. Negative slopes until 8, positive slopes until 10, negative slopes until 12. Okay, so the question is, do I have a point of inflection? Yes I do. It doesn't matter that it's a sharp turn, please don't get hung up at that. So notice g double prime x goes from positive to negative values now. I would, of course, if I'm going to make a sign chart of g double prime x, I would have to label right over here that g double prime x equals f prime x. Should have mentioned that before. Once we get one, we might as well write both. And now for your justification, you could say because g double prime x changes signs, or just talk about the graph. Since this is the graph of f, you can say the graph of f goes from increasing to decreasing at this point. Either way works. All right, so now we need to talk about part C. Part C, find the absolute max and min values on the interval. Now the fact that we're talking about absolute max and min values means you're talking about y values, the y coordinates. And let's just go ahead and see who can win the absolute max or min awards. They're talking about the absolute max or min of G. So let's use this sign chart that we made to find out who is actually in the running for absolute maxes and mins. So I have a graph that is somewhere. It decreases, increases, increases some more, decreases, decreases some more. So this means that 12 and -2 could win the minimums, and 6 and 4 can win the maximums. Now off to the side, I'm just going to keep track of what I need. I need to know what is g of -4, what is g of -2, what is g of 6, and what is g of 12. So I'm simply going to find all those values. The biggest one wins, the smallest one loses. All right. Now to make things go a little bit quicker, I'm just going to write in the areas. 1/2 base times height. So this is the 1/2, the base is 2, the height is 4. 1/2, 2 times 4 is 4, but it's below the curve, so that's a -4. That's a +4. Well, I'm just going to put those two together. And that's going to be 8 and 8 and -8 and -4. So I'm going to use those areas to help me do this work really quick. Okay, so the first thing I need to know is what is g of -4. And if I go to find g of -4, you'll notice here it's the area from 2 to -4. But you see how these are in the wrong places? We've done this before. We're going to have to flip these and put a negative in front. So it's going to be a negative. And I'm going to flip these. So I get a negative in front, and now I need this area from -4 to 2. From -4 to 2, it's this -4 plus this 8. -4 plus 8 is a 4, so it is a negative, but I got from flipping it 4. Alright, the next one I need is -2. Same scenario, if I put a -2 up here, so g of -2, if I put a -2 up here, it's going to be from 2 to -2. I'm going to have to flip them again. So basically, there's going to be a negative in front again, and now it's -2 to 2. And from -2 to 2, it's an 8, so it's -8. Alright, now let's find g of 6. So g of 6, and this time no flipping necessary, it's already in the right order. So g of 6 is just the area, no negative in front, from just simply 2 to 6. So the area from 2 to 6 is 8. And now we need g of 12, which is the area from 2 to 12. And that's 8 minus 8. So 8 minus 8 is 0, minus 4 is a -4. Alright, so I'm going to look at all these, and I'm just going to say the absolute minimum. Now, my actual answer for the absolute minimum is -8. This is the x-coordinate. So -8 is my absolute minimum. And my absolute maximum is +8. I'm going to turn around and check the answer on my computer. Looks awesome. Okay. Alright, the last question asks, oh, he's gone! The last question asks, when will g of x be less than or equal to 0? So we want to know, when will g of x be less than or equal to 0? Now, let's just go ahead and track these, okay? We said this was at a height of -4, and then -8, and now we're up here at 8, and now we're down here at -4. If the graph goes down, up, down, it had to hit 0 somewhere in here, and it had to hit a height of 0 somewhere in here. And we got to find those values, and it's actually not going to be very difficult. The first time when I know it equals 0 is at 2. They did not give me an initial position, but they did. Put a 2 there. The area from 2 to 2 is 0. So it's important that we know g of 2 is at 0. Okay? When does it hit 0 again? Well, look at it. If you add 8, let's go from 2 to 10. The area is from 2 to whatever. If you add 8 and subtract 8, you're back to 0 again. So at 10, we were at 0. So the question is, when was it below 0? It was below, is it below 0 or less than 0? Yeah, okay. So where was it less than 0? Well, over here, these are all, I know I didn't draw up the scale, but these are all less than 0, and these are less than 0, just looking at the values. So less than 0 when x was between -4 and 2, which of course you could write as -4 to 2, and from 10 to 12. Is that the only thing they ask for? The interval, yep. Oh, it says greater than or equal to 0, so sorry, these are brackets. Or, in other words, these are equal signs here. Okay, that's it. Nothing else to that one. I'm sure you guys did great on it. Have a good day. See you tomorrow.